Listen, I want you to right now imagine the fastest thing you can possibly think of. Forget about your family sedan. Forget about a Ferrari. We are talking about serious hardware here. Imagine we built a rocket, and we have an infinite amount of fuel, a tank the size of the Pacific Ocean. We get in, buckle up, I hope those straps are tight, and we stomp on the gas, pedal to the metal. You get pressed into the seat. The speedometer goes crazy, 1,000 miles an hour, 10,000, a million. We fly past the moon like it's a road sign on the highway. Mars is left somewhere back in the dust, and we keep accelerating. It feels like nothing can stop us, right? If I have a bigger engine, I should go faster. That's the law of the jungle. That's the rule of the New Jersey Turnpike. If you push the pedal, you go faster. But right here is where the universe starts acting strange, very strange. As the needle on the speedometer creeps up to that magic number, about 670 million miles per hour, something unimaginable happens. Even though the engines are roaring, even though we are burning the energy of entire stars, the acceleration disappears. It's like someone grabbed the rocket by the tail. We push harder. We burn all the fuel in the galaxy. But the needle freezes. It quivers, but it won't budge another inch. We've hit a wall. Not a brick wall. A wall of reality itself. And that drives you crazy, doesn't it? It's annoying. What the heck? Who made this rule? It feels like some kind of cosmic conspiracy, like God or nature, call it what you want, put a cop with a radar gun in the middle of the void and said, "That's it, pal, no further. That's the law." In school they tell us, "Oh, that's just the speed of light. Nothing can move faster than light." And we nod, write it in our notebooks, and go to lunch. But did you ever stop to ask, why? Why is light so special? Does it have privileges? A membership card to an elite club? Why is the speed limit exactly that number? Why not double? Why not infinity? You see, most people think about this the wrong way. They think light is the boss. That light sets the rules of the road. But let me let you in on a little secret. Light has nothing to do with it. Light just got unlucky. It's not the lawmaker. It's just the courier, the mailman, running as fast as the road allows. If we took all the light out of the universe, if we lived in total darkness, that limit would still be there. That wall isn't going anywhere. The problem isn't your rocket. The problem isn't the engine. The problem isn't even your engineering skills. The problem is the geometry of the place we live in, the geometry of space and time. Many people think the speed of light is about light, but really it's the speed of something much more fundamental. It's the speed of now. It's the speed of causality. And believe me, light just happened to be the only thing light enough to hit that limit. Let's forget about light for a minute. Switch it off. Imagine we are in a completely pitch-black room. Physicists do this often. Strip away the junk to look at the bare skeleton of the problem. That letter C in the equations doesn't actually belong to light. Light is just renting that speed. Why? Because photons, particles of light, have no mass. They weigh nothing. Zero. Zilch. They have no baggage. If you didn't have any mass, you'd be flying at that speed too. Instantly. From the moment you were born, you'd be tearing along at the limit of the possible. Any particle in the universe without extra weight is obligated to move at this speed. Gravitational waves, speed c. Gluons, speed c. So c isn't the speed of light. It's the maximum speed of information transfer in the universe. It's the speed of cause and effect. And here is why that matters. Imagine there was no speed c. Imagine information could travel instantly. Then, if something happens here, the entire universe knows about it in the same second. Everything is connected to everything instantly. It would be chaos. But our universe is a big, spacious place. And for an event in point A to affect point B, time must pass. The courier has to arrive. The most beautiful example here is gravity. Old man Newton, the greatest mind, thought gravity worked instantly, like the sun holds the earth on an invisible, rigid chain. If the sun jerks, the earth jerks in the same instant. But Einstein said, no, that won't do. Let's try an experiment. Right now. I am an evil space wizard. I snap my fingers and the sun just vanishes. Poof. Gone. What happens on Earth? According to Newton, we immediately fly off into deep space, into the dark. Instantly. The chain snapped. But here's what actually happens. And it just blows your mind. I snap my fingers. The sun is gone. But you, sitting on the beach in Miami, keep getting a tan. You see the sun in the sky. You feel its warmth on your skin. The plants keep photosynthesizing. The tides work like clockwork. The Earth continues to orbit around an empty spot, around nothing. Why? Because gravity isn't a chain. It's a ripple on the water. And that ripple needs time to get from the center of the solar system to us. It needs 8 minutes and 20 seconds. For 8 minutes, we live in an illusion. We orbit a ghost. We are warmed by the heat of a star that doesn't exist anymore. The gravitational courier with the bad news hasn't reached our doorstep yet. Only after 8 minutes and 20 seconds will the sky suddenly turn black, and the Earth will tear off its orbit, flying into the cold infinite. That is what this limit is. It's a guarantee that events happen in order. It prevents everything from happening at once. The space between things is a buffer, and the speed of light is the speed at which that buffer updates. But if information can't spread instantly, that leads us to a very strange conclusion. If I see an event now and you see it a bit later, does a single now even exist for everyone? The answer is no. And to prove it, we have to buy train tickets. Imagine a train station. Pouring rain. You're standing on the platform, right in the middle. It's cold, smells like ozone and wet asphalt. Approaching the platform at huge speed is a train, a super express. And in the very center of that train, in the dining car, I'm sitting with a cup of coffee. I zoom right past you. At the exact moment we are nose to nose, something dramatic happens. Flash. A crack of thunder. 2 lightning bolts strike simultaneously. One at the front of the platform, one at the back. You, standing exactly in the middle, see both flashes at the same instant. For you, it is an absolute fact. Bam and bam. Simultaneous. You saw it with your own eyes. But now let's look at it from my perspective. From the dining car, I am also exactly in the middle between the lightning strikes. But there is one detail. My train is moving. It's rushing forward. The light from both bolts starts its journey toward me. But while that light is flying, my train shifts forward. I am literally driving toward the light from the front bolt, and I am running away from the light of the back bolt. The light from the front travels a shorter distance to reach my eyes. The light from the back has to catch up to me, and since the speed of light is always the same, remember, that's the law, the light from the front reaches me first. I take a sip of coffee. I see the flash in front. A fraction of a second passes, and only then do I see the flash from behind. If you ask me what happened, I will say with total confidence, first lightning struck the head of the train, then the tail. And here's the nightmare for our common sense. We both stand before a judge. You say, they hit at the same time. I say, no, first the front, then the back. Who is right? Whose watch is broken? Who went crazy? The answer is terrifyingly simple. Nobody. We are both absolutely right. In my reality, events happen one after another. In your reality, they happen simultaneously. And this isn't an illusion of perception. It is a physical truth. Do you see where this leads? The word simultaneous loses all meaning unless we agree on how fast we are moving. What is now for you might be past or future for me. We are used to thinking of time as a giant cosmic clock. Tick-tock. A second passes for me. A second for a guy on Jupiter. A universal metronome. But Einstein showed there is no clock. My now doesn't match your now if we are moving relative to each other. This completely shatters our picture of the world. Past, present, and future aren't rigid shelves in a closet. They are flexible, plastic. If your now and my now don't match, it means time isn't a straight line flowing left to right. Time is something else entirely. Time is more like bread. Yes, a loaf of bread. Imagine the universe not as an empty room where things happen, but as a giant loaf of bread. A long, long French baguette. The width and height of this loaf, that's our space. And the length, that's time. One end is the Big Bang, the other is the distant future. Now, what is now? What is the present moment? It's when we take a knife and cut a thin slice across the loaf. Everything caught in that slice. Me, you, your dog, the star Beetlejuice. All of that exists in the same moment of now. If you and I are sitting on the couch not moving, our knives cut the bread at the same angle. Strictly perpendicular. Our slices match. Our now is the same. But remember the train. Remember that motion changes simultaneity. As soon as you start moving, your knife tilts. It's pure geometry. If you move through space, you start slicing time at an angle. Your slice of now is no longer perpendicular. It goes diagonally. In normal life, you don't notice this. When you walk to the fridge, your speed is nothing compared to light. The tilt of your knife is a billionth of a degree. On the scale of a kitchen, that time difference is less than the flap of a fly's wing. Nobody notices. But what if the loaf of bread is really huge? What if we are slicing it across millions of light years? Even a tiny tilt of the knife here on Earth creates a giant divergence at the other end of the loaf. Let's look at the Andromeda galaxy. It's far away. 2.5 million light years. Imagine there's an alien sitting there. Let's call him Zorg. Zorg is a fleet admiral. And right now, he's sitting in front of a big red button. He's thinking, should I attack Earth or not? You're sitting on your couch. For you, now is the moment Zorg is thinking. He hasn't decided yet, but suddenly you want a sandwich. You get up and walk across the room toward Andromeda. You walk slowly, normal pace. But you started moving. Your knife of time tilted. And because Andromeda is so far away, that tiny tilt slices off a huge chunk of time over there. Simply by walking toward Andromeda, you shifted your now into its future. In your new slice of reality, Zorg has already made the decision. He already pushed the button. The fleet has already launched. It has already happened. It is a fact of your reality. But wait, you change your mind. You turn around and walk away from Andromeda, back to the couch. Your knife tilts the other way. Now your slice of reality cuts through Andromeda's past. In this now, Zorg hasn't even woken up yet. He hasn't had breakfast, let alone thought about war. It sounds like the ravings of a madman, I know. But this is the strict logic of special relativity. Just by changing direction in your living room, you travel days or even weeks back and forth in time for events in a distant galaxy. What does this mean for us? It means the division into past, present, and future is an illusion. The entire history of the universe is a loaf of bread already baked. All the slices already exist. The future is already written, we just haven't read it yet. But if time and space are so connected, if they are one whole, a question arises. How fast are we actually moving through this loaf? The answer might shock you. You aren't standing still. Even when you sleep in your bed, you are racing through reality at the maximum speed possible. Hold on to your hats, because I'm about to tell you something that sounds like total nonsense, but it's the deepest truth we know about the universe. You cannot accelerate to the speed of light. Do you know why? Because you are already moving at the speed of light. Yes, you, right now, sitting in the chair, not blinking. You, your cat, this table, planet Earth itself. Everything in the universe is rushing through space-time at the exact same unchanging speed. At speed c. Wait, don't turn off the video. Let me explain. It's simpler than it seems. We are used to thinking space and time are different things, but we already figured out it's one big loaf of bread, one field, space-time, 4 dimensions, 3 for movement, forward, back, left, right, up, down. And the 4th, time. Imagine you're driving a car in a huge empty parking lot. Your car has one quirk. The gas pedal is welded to the floor. You can't go faster or slower. Your speedometer is glued to the mark, speed of light. The only thing you have is a steering wheel. You can choose direction. On this parking lot, there are 2 axes. The axis north is space. The axis east is time. Right now, sitting there looking at the screen, your car is driving strictly east. You aren't moving in space. You are sitting still. That means 100% of your speed, all your gas, is being spent on moving through time. You are moving into the future at maximum speed. Your watch ticks. Second after second. You are aging at maximum velocity. But then you decide to get up and get coffee. You turn the wheel. You point the nose of the car slightly north, into space. But remember, your total speed is constant. If you started moving north, you must move a little slower to the east. That's simple geometry. Pythagoras would understand. To get speed in space, you had to borrow it from time. In normal life, you borrow so little speed nobody notices. But get in my rocket. We turn the wheel sharply north. We accelerate in space to 90% of the speed of light. Look at the gauges. Your car is tearing through space, engine roaring. But look at the time axis. Your progress to the east has almost stopped. For a guy who stayed in the parking lot, on Earth, you almost stopped moving in time. Your watch slowed down. Your heart beats slower. Your thoughts flow like thick honey. You don't feel it. For you, everything is normal. But to the universe, you traded your time for distance. And here is the final question. What happens if we turn the wheel all the way? If we point the car strictly north, strictly into space, then all your speed, all 100%, goes into space. Nothing is left for movement in time. Zero. Your watch stops. Time freezes for you. You stop aging. You stop changing. You become a photograph. That is why you can't move faster than light in space, because you have no more resources to borrow from time. You spent the whole budget. You can't drive north faster than your engine allows, even if you stop driving east entirely. The speed of light isn't a limit on motion. It is simply the full length of the vector of your existence. You are always moving at the speed of light. The question is only where you spend that speed. On moving your rear end to another chair, or on aging and seeing tomorrow. But there is a problem. When we try to turn that wheel, when we try to pump speed from time to space, nature hands us a bill. And that bill isn't paid in money, it's paid in mass. Okay, let's get back in our rocket. You're stubborn. You say, Richard, to hell with the budget. I'll just build a bigger engine. You think it works like the old market. You pay energy, you get speed. $1 a mile. But when we get close to the light barrier, the exchange rate starts jumping like crazy. Here comes the most famous equation in history. E equals mc squared. E equals mc squared. Energy equals mass times the speed of light squared. Usually people think this equation is about the atomic bomb, about turning a small piece of matter into a huge explosion. And that's true. But the equals sign works both ways. Energy is mass. Mass is energy. It's the same thing, just in different packaging. Do you know what that means practically? It means energy weighs something. If you take a bowling ball and heat it up, add thermal energy, it gets heavier. A tiny fraction of a gram, but heavier. If you wind up a spring in a watch, the watch becomes heavier than when the spring is relaxed. Now back to the rocket. We fly fast. We pour oceans of fuel into the engines. We add kinetic energy. Where does that energy go? At first, it goes into increasing speed, but the closer you get to C, the less willing space is to let you accelerate. Remember the geometry? You almost spent your whole vector on the space axis. Since the energy has nowhere to go, and it can't disappear, it does the only thing left. It turns into mass. It becomes part of you. You literally get heavier. Your inertia grows. Imagine running a marathon, but with every step, someone puts another lead vest on you. At 90% of light speed, your mass doubles. If you weighed 170 pounds, now you weigh 340. Your engine has to push double the weight. You press the gas harder, burn more fuel, but that energy turns into mass again. It's a vicious cycle. You are feeding the monster that stops you from running. At 99% of light speed, every gram of your body, every eyelash, becomes incredibly heavy. Trying to blink at that speed is like trying to lift a bag of cement with your eyelids. Of course, inside the ship you won't feel it. For you, everything is normal. But to an outside observer trying to push you, you become immovable. And here is the finale, 99.9%. You add more energy, more. The energy of the entire galaxy is thrown into the furnace. But you don't reach 100%. You never will. Because to reach the exact speed of light, your mass would have to become infinite. And to move infinite mass requires infinite energy. Infinity is a lot. It's more than there is in the entire universe. Nature puts a bill with an infinite number of zeros in front of you and says, pay up or get out. That is why you, having mass, are doomed to always trail behind. You are too fat for this party. But there is someone in the universe who doesn't pay bills, someone on an eternal diet, the photon, the particle of light. It has no rest mass. It weighs nothing. It doesn't need to accelerate. It is born already at maximum speed. It lives on the limit. And if you could become a photon, if you could drop all that extra weight, oh, what you would see would make you forget your name. Let's make one last, wildest jump of imagination. Let's imagine we shed our mass. We became pure energy. We became light. What do we see? We know that as we approach light speed, time slows down. But what happens when you reach the limit? The math gives a very clear answer, but our brain refuses to accept it. At the speed of light, time stops. Completely. Absolutely. Imagine you are a photon born in the depths of a distant star in the Andromeda galaxy. You burst out and fly through space toward Earth. For me, an astronomer looking through a telescope in California, your journey takes 2.5 million years. I see you and think, wow, this light has been flying to me since my ancestors were learning to make stone axes. It's an epic journey. Civilizations rose and died while you flew. But for you, for the photon, for you, not a moment has passed. Not a second, not a millisecond. In your frame of reference, the moment you left the star and the moment you smashed into my retina is the same moment. You don't age. You don't feel time flow. You don't get bored in flight. For you, the concept of flight doesn't exist. You are born and you die in the same now. Light is the only thing in the universe that is eternally young. Photons from the Big Bang passing through the room right now are just as fresh as they were 13 billion years ago. For them, the birth of the universe is happening right now. But that's only half the weirdness. Remember, space and time are connected? If you steal everything from time, what happens to space? It shrinks. In the direction of motion, distances get shorter. The faster you fly, the closer the destination. If you fly at the speed of light, the compression factor becomes infinite. Distance becomes zero. Think about that. The distance between Andromeda and Earth for a photon is zero. From the point of view of light, our huge, giant universe simply doesn't exist. Along its flight path, the universe is flattened into a plane, into a 2D sheet of paper. For a photon, the star that emitted it and your eye that absorbed it are physically touching. They are at the same point. It's like a kiss across an ocean of void. We think of light as a traveler, but really, light is an instantaneous contact between 2 points of space-time. It sounds like mysticism, but it's dry Einsteinian physics. From light's perspective, there is no separation, no distance, no delay. The universe for light is a singularity where everything is connected to everything instantly. And that brings us to a thought that gives me goosebumps. The only reason we see the world in 3D, the reason we feel distance, and the reason we have time to think before we act, is that we are heavy. Our mass ties us to time and creates space. We are locked in slow motion. But what if we find a loophole? We humans love breaking rules. What if we build a warp drive? Or find a wormhole? What if we actually outrun that beam of light? What if we arrive at the finish line before the photon, for whom the trip takes 0 seconds? Then we wouldn't just break the speedometer. We would break logic itself. We would break history. So why is the universe such a strict school teacher? Why does she smack our hands with a ruler every time we try to go FTL? Many think it's just a technical problem, that we just aren't smart enough yet. But the problem isn't engineering. The problem is logic. If you allow faster than light travel, you kill the most important thing holding reality together. You kill causality. Remember our trains? Remember that the order of events depends on the observer? In special relativity, if 2 events are separated by space, one guy can see A happen before B, and another can see B happen before A. And that's fine, as long as information can't get from one to the other. But if you can move faster than light, you can outrun that order. You can find a frame of reference where the effect happens before the cause. Let me give you an example that will give you a headache. Imagine we have a super fast bullet. faster than light. We have a shooter and a target. In the normal world, the order is ironclad. 1. Shooter pulls trigger. 2. Bullet flies. 3. Hole appears in target. Everyone is happy except the target. But if the bullet flies faster than light, there exists an observer, say a guy flying by on a rocket, for whom the geometry of time tilts. Do you know what he sees? First, a hole appears in the target. Then, the bullet flies out of the hole back into the gun. And only then does the shooter pull the trigger. You say, so what, Richard? It's just an optical illusion, like a movie played backward. No, in relativity, that isn't an illusion. That is that observer's reality. For him, the target died before the shot. Now let's make it worse. Imagine the target has a sensor. As soon as a hole appears, it sends an instant signal back to the shooter. I'm hit. Since the signal is superluminal, it can arrive in the past. Scenario: you stand with a gun. You aim. Suddenly a light blinks in front of you. Target destroyed. You see this before you pull the trigger. You look at the light, get surprised, and decide not to shoot. You put the gun down. You didn't pull the trigger. The bullet didn't fly. But the light is on. The hole is in the target. Where did the hole come from if you didn't shoot? The universe just backed itself into a logical loop with no exit. This is called the grandfather paradox. Only here you are killing logic. If the effect can cancel the cause, history cannot be written. The world turns into chaos. Events happen without reasons. Reality would simply crumble. That is why the speed of light is the law. It's not just a maximum speed. It's a wall that protects us from insanity. It's a wall that separates yesterday from tomorrow. But you know, physicists are picky people. We always look for holes in the fence. And there is one phenomenon that seems to spit on all these rules. Something Einstein called spooky action at a distance. We are talking about quantum entanglement. It sounds complex, but the idea is simple as a pair of socks. Imagine we take two subatomic particles, two electrons. We smash them together and they become entangled. It's like a marriage. No divorce allowed. Their fates are now linked. If one spins up, the other must spin down. The balance of the universe must be kept. Now we separate them. I keep one in my lab in Pasadena. I give the other to you and send you to the edge of the universe. We agree, exactly at noon. You look at your electron and I look at mine. According to quantum mechanics, until we look, the electrons haven't decided. They are spinning every way at once. But as soon as I open my box and see my electron spinning up, bam! In that exact same millisecond, your electron on the other end of the universe decides to spin down. Instantly, faster than light, faster than the thought of God. And here you jump up and scream, Richard, we did it. Let's build a quantum telegraph. The idea seems genius. I force my electron to spin up. You instantly see yours spin down, and you know I sent a signal. We can chat across the universe in real time. Einstein was wrong, but here nature, with a sly smile, pulls her ace card. She says, not so fast, boys. The problem is, I cannot force my electron to spin up. When I open the box, the result is totally random. 50-50, heads or tails. I don't control it, I'm just an observer. I see up, you see down. Next time I see down, you see up. We see perfect correlation. But inside that noise, there is no message. I can't modulate the signal. It's like having magic coins. If I flip heads, you always get tails. But I can't choose to flip heads to send you the letter A. It's a genius defense. Nature allowed particles to feel each other instantly, so the universe stays whole. But she forbade us from using that link to send info. Causality is saved. You can't send a message faster than light because you can't control the randomness. In the end, many people leave my lectures a bit upset. They feel cheated. They say, Richard, you just told us we are trapped, that we will never reach the stars on a weekend. We are prisoners of light speed. And I understand that feeling. We humans don't like being told no. But let me offer you a different perspective. Let me show you why this limit is the best thing that could happen to our universe. Imagine for a second that this limit didn't exist. Imagine the speed of light was infinite. Do you think that would be freedom? No. That would be the end. If light and info traveled instantly, everything that could happen would happen at once. Imagine a book. A good, thick history book. It has a beginning, a middle, and an end. Drama, development. Infinite light speed is like if all the words in that book were printed on a single page, right on top of each other. It's not a story. It's a black ink blot. It's noise. Without this limit, gravity would collapse the universe into a black hole the moment it was born. Stars would burn all their fuel in a fraction of a second. Light from every star would reach us simultaneously, and the night sky would be blinding white, burning us to ash. The speed of light isn't a prison wall. It's a protective barrier. It's a dam holding back chaos. It forces events to get in line. It creates before and after. It gives us the precious gift of time. Because light needs time to get from the sun to Earth, we have those 8 minutes of warmth. Because signals in your brain need time to move from neuron to neuron, you have the ability to think. You have a thought process. The speed limit is what allows the universe to stretch the pleasure of existence over billions of years. And look at the beauty it creates. When you go out at night and look up, you don't see the universe as it is now. You are looking into a giant museum. The moon is a second ago. Jupiter is an hour ago. Andromeda is 2 million years ago. We see the history of creation laid out before us in layers. So yes, we can't move faster than light. We can't outrun our reflection. But this limit is the glue holding reality together. It's the rule of the game that makes the game possible. Nature isn't greedy, she's just tidy. She said, let everything have its turn. So next time you look at the stars and feel sad about how far away they are, don't be. Remember, that distance, that delay, that impossibility of instant contact is exactly what gives you the space to be you. It's what gives you the time to live. And in my book, that's a pretty damn good deal.